Okay. And then I'm going to be able to watch it from here as well. I should. Yep, it's turned off. Waiting.
You're on Reels.
So then we're able to see it. I wonder if you can make this bigger. Because are you able to see that?
Mm-hmm.
Can you read the comments?
Mm-hmm.
Okay.
Plus, I can also monitor one here.
Oh, yeah.
Yeah.
I have a tripod as well.
But if I've got your page in here, right?
Make sure your volume's down.
Oh, always. It's never turned up. Okay. There we go.
Oh, well, let's turn it up.
All right.
Waiting and waiting. Let me actually do this. Mm-hmm. You might have to refresh it. Yeah. Yep. Okay. Are you ready?
I'm ready. What are we going to talk about today?
Well, we're going to talk obviously about the El Nino. But first, as we kind of wait for people to join, first off, and I guess I also have people here on Facebook as well, or on YouTube as well. Can't forget about my YouTube people.
Yep.
Let's see if we can get this pulled up. There we go. So yeah, if you're watching from Facebook, welcome. If you're watching from YouTube, also welcome. And let's talk about the current weather patterns again while we kind of wait for people to get on here. So we are looking at also, first thing I want to say, share this video so that way people can watch it live. And we're going to take questions at the end. So share this video now so that way people can kind of join in. And just really simple, talking about El Nino weather patterns. There's a lot to talk about with this because we're going into what we call kind of a super El Nino, which basically just means we're going into record high temperatures, sea surface temperatures out there in the Pacific. So. Right.
And, you know, when I saw you were going to do this, I'm like, I probably would like to join in because when
you know a lot about this.
Well, when you do a winter outlook, which I've done for 30 years now, the number one, I look at a ton of things, but the number one thing I look at is the sea surface temperatures and specifically El Nino or La Nina, which we're going to get into. So I'm like, I want to get involved in that. So yeah.
Yeah. And I think a lot of people also assume, you know, it's some overhyped thing or it's something that, you know, is, oh, how much does it actually predict and how true is it actually? But it is, like, we look at it a lot. Like, it is very, very important for how we kind of forecast, specifically the winter time. Mainly, it impacts the winter time because you have such a polar opposites in temperature. In the summer, you don't have as much fluctuation, but especially in winter, it's, I want to use the term more sensitive. It's a lot more sensitive to how the weather kind of reacts. Whereas the summer, we may get fluctuation in heat, but we know that it's not going to be this very fine line between rain and snow. But in the wintertime, it is. So
yeah, and you know, it peaks, you know, late fall into the first part, around Christmas,
right,
in wintertime. So that's when you have the biggest impact. Now, I had done a video a while back about also, you're going to talk about the years of the, you know, these very strong El Ninos, and what it meant for us in the summer. And our summers were generally a little drier than normal, which folks are asking for rain again. And also they were generally a little cooler than normal. And I just had a graphic tonight where today we hit 90. We've only had 16 days this winter this summer that we've hit 90. Last year we had 36.
30. Yeah, I remember that. Yeah.
So, I mean, so it's going along. You know, I always say you predict the future by looking at the past. And so the summer's lining up, and we're going to talk about what it could mean for the winter.
Yeah. So we've got almost 100 people there watching. Again, go ahead and share it so that way people can kind of join in and see it now live, because we're going to answer questions at the end. But we're going to talk all about El Ninos, how they compare to La Ninas, and we are going to look at the past to forecast for the future, forecast for this winter. So let's get on with it. So El Nino, the main thing, the main definition, and I think I have the definition in the next graphic here, but it's all about how sea surface temperatures and those temps are distributed throughout kind of the world. So it dictates a lot that happens in the Pacific. It dictates what happens here, what happens over in Asia, what happens even in Africa. So it dictates actually a lot, especially in those winter months. And El Nino, you can kind of see this, how it's displayed here. Normally in an El Nino winter, we have a little bit warmer up in the northern plains, Midwest, and drier. So we talk about warmer and drier. And actually down there near the Gulf is where they have a lot more wetter conditions, a lot more rain down there. Again, you can kind of just see where that jet stream sweeps across, and we'll kind of talk about why. So we've got the polar jet stream and the tropical. So those all, the jet streams mixed with the pressure systems kind of go all the way into one. And looking at the definitions here, I tried not to be too scientific, but it's like hard to generalize it a little bit. But El Nino basically means low pressure, which is rising air off of the Pacific Northwest. So think of areas there near Alaska or off of Washington and Oregon, all the way out there in the Pacific. And it brings a high pressure over the plains and Midwest. So you have all of this warm air that's rising, and then it has to be distributed. So when it gets distributed up and out, that's what creates the high pressure system kind of over our area. High pressure is sinking air. So again, this normally leads to warmer and drier conditions in those winter months. A La Nina, go ahead.
Oh, I was going to, an easy way to remember this, because when I do my winter outlooks, I look like off the southeast coast. So basically think of where the sea surface temperatures are warmer, you think of warm air that rises, right? So where the sea surface temperatures are warmer, the air tends to rise, which is what you're showing here with El Nino. And when the sea surface temperatures are cooler, as you've got with La Nina, that tends to be falling air. So high pressure, low pressure. So that if there's an easy way to remember that, just think where the water is warmer than normal, you probably have some rising of the air, which is creating the low pressures that you're talking about there.
Yeah. And the La Nina, which we just came out of last year, it was a weak La Nina, but it was still a La Nina. This is what we had just this past winter, and we had quite a bit of snow actually. And normally that's what we forecast with La Ninas is wetter and colder. So it was actually a pretty textbook La Nina. High pressure there off of the Pacific, and that polar jet stream kind of falls down. It's not as impacted by that high pressure, and it falls down in the Midwest easier. So you get a lot of clipper systems, and you just get cooler air coming down into the area. You mix that with moisture, that's how you get snow there in the wintertime. So you can kind of just see here El Nino, La Nina pressure patterns there in December and February. Again, kind of that cooler and warmer, that talking about the difference there in the atmosphere. So SST just means sea surface temperatures. And when the sea surface temperatures alter the pattern of convection is just heat transferring through fluids. So liquids and gases, which water and then gases are all throughout the atmosphere. And the tropical, subtropical atmospheric circulation. So again, it all depends on what's happening down there in the Pacific near the equator is where we look at the sea surface temperatures, and it adjusts the temperatures that we see all throughout the world. So this is August 4th. This was the snapshot that I got from NOAA. And you can see those much warmer temperatures there near the equator. And again, that's where we look at the sea surface temperatures to forecast for El Nino and La Nina conditions. So this was actually just a week ago. What's the date today? The 10th?
Yeah, so 6 days ago.
Yeah, so 6 days ago. And you can see that warming taking place there near the equator. So do you want to talk about these? So now we're kind of going through different maps because we like to compare to other El Nino years.
Yep. So can you go back to the other one real quick? So this one is the actual, what you're looking at with the temperatures, and like she just talked about, where we see the warmest temps. Now let's go to the other one you had. And so now what we're looking at here, if you look, near South America is where we see the greatest warmth as far as the sea surface temperature, what we call anomaly, which is above or below. And then it does trail out, along the equator. But, and you got some graphics on this. When we look at El Niños, we want to see where they're located. Centrally, we call that a Modoki El Nino, or near the South America. So this one clearly right now is near South America. I actually looked before coming here, and the temperature anomaly there off the coast of South America is about 1 degree Celsius warmer than it is in the middle. And you can see that from your graphics. So we're clearly on an east-based El Nino pattern. That looks like where we're headed with that. And it's interesting too. I know we're talking El Nino, but it's interesting too. I also look at that area up there across the North Pacific. Yeah.
Yeah, I was going to say.
Yeah. Sometimes we call it the warm blob.
Oh, I'm not.
The warm blob.
That's really scientific.
Yeah, well, sometimes we use weird words, but yeah. And so we look at the things like that too. But clearly, if you look at that, those are the two things that catch your attention.
Yeah. Really simple explanation. The equator is where we have the warmest temperatures, because when you think about the axis and the tilt that we're on, that's where they see the most sunlight. So that's just a simple explanation of why we have the warmest waters just to begin with on the equator, is because of where it's located. And again, with the axis and the tilt, that's where we have kind of the most direct rays of sunlight. Okay, so then this was August of last year when we were in a La Nina pattern.
So clearly a big difference. La Nina is the opposite. So you have cooler than normal sea surface temperatures. This one was centered also more centrally located. If you notice there, you'd see the blue shadings more in the central. Again, that's kind of a key for us. But clearly a big difference in these patterns. So the cooler than normal, we call that La Nina, and the warmer than normal is El Nino. And there's been a really quick flip. I mean, if just in 1 year from your graphics there's been a major change in our temperatures.
And the main reason for that is we have trade winds. So trade winds that flow normally east to west, and they are sometimes greater impacted. There's a lot of things that can kind of go into why trade winds are weaker. But actually, during an El Nino year, we were actually just talking about this before we started the video, hurricanes are a lot less likely. So when you have those weakening trade winds, nothing is pushing that warm water to the west. The force and what's moving and relocating that water is, again, not as impactful. So that warm water kind of just stays stagnant. Now with this, in a La Nina year, we do have those stronger trade winds. And there is also a little bit of a tilt there called the Coriolis force, and that all has to do with the Earth's tilt. But that's how we can get some of those warm waters actually moving back up north, is through that Coriolis force. So one way I've used this analogy before is, you have a bowl of hot soup, and you take a spoon of the soup out, and it's hot, and what do you do? You blow on it, right? You blow on it. So what happens is, basically, when these patterns change, it really has to do with a couple things, but it really has to do with the winds you were just talking about. So if the winds relax, then we start to see the warmer water at the surface build up. But like blowing on that spoon of the hot soup, if you tend to blow the warmer waters one direction, the cooler waters up well underneath. And so what happened here that you're looking at here with the La Nina is we were blowing the warmer sea surface temperatures off west, the colder air was coming up. Now imagine reversing it, and you're bringing the warmer waters from the west back to the east. And that's why we see the warmer air here. So it has to do with the winds and how they kind of change the sea surface temperatures. If you like displacing, because it's not necessarily, some years we've got exceptionally warmer just for no reason. There's always warm sea surface temperatures. It's just where they get moved to. So that's another kind of important tidbit. So this is a comparable year to kind of what we might see this year. 2015 into 2016 was a very strong El Nino year. Again, El Nino is what we are going into this winter time. You can see the warm sea surface temperatures, and these aren't nearly as warm as what it's showing right now. Right. If we want to go back, hopefully, right there. So this is what it's showing August 7th of this year. And this is what it was showing August 7th of 2015. We can see the difference that this year is actually showing even warmer sea surface temperatures. And 2015 ended up being the strongest on record. with sea surface temperatures.
Yeah, and I think you've got a graphic coming up. But so yeah,
I got a lot of graphics.
You got a lot of graphics. 25, right?
Yeah.
20, 25, 26.
Maybe
Yeah.
more, I don't know.
So there were 82, 83, 97, 98, and what you have 15, 16 as far as like recorded history. You know, we have satellite images and what have you. Now, there was one in 1877 to 1878 that.
Is that fair? I mean, come on.
Well, I mean,
how accurately can they?
I know, but they had ships out there. They measured the temperatures. So, okay, so this one is on course to be the strongest in our recorded history as far as, you know, legit. But 1877, 1878, there was one. They estimated the sea surface temperatures peaked at about 3.5 to 3.6 degrees Celsius above normal. That's massive. So, you know, right now we're looking at around 2, give or take, but we're not completely done. So yeah, the answer is, as far as the strongest in reliable recorded history, we're probably headed there, and we might rival the 1877.
We didn't start keeping accurate, more precise weather data until the 50s.
Yeah, even tornadoes. We didn't really keep detailed record on tornadoes until 1950. And you realize that the pre-satellite era, we didn't have things like what we're looking at, you know, because we didn't really know. Now we can get all of this information. So, but yeah, we're definitely headed for maybe the strongest, or definitely the second strongest. I think, on record. On record.
There we go. All right, so this is 1982. This was another El Nino year. Again, we can kind of see those warm sea surface temperatures. This was August 7th. So again, still the same date. But what we are going to talk about is also it peaks. Sea surface temperatures peak at different times of the year. Normally when we see them peak, they're right at the end of summer. It kind of alters a little bit of that winter pattern versus if an El Nino, say, peaks in the fall. So this kind of, was this the peak temperature? Was it in August or was it later? Do you know?
I want to say it was probably closer to November, early December. As a general rule, they generally peak near Christmas time. So this would have still been fairly early on for the 82, 83 El Nino. But, you know, interesting, this was the first time it really got attention. Because again, we knew this was fluctuating, and on all this, but 82, 83 was the first time that that's the first time in a satellite era that we really saw something like this. And so this was really the first one where we're like, this is
noticeable.
Yes. So this was the first one that we really started to notice.
Yeah. All right. So you sent some of these graphics to me. But this is just talking about where we are seeing those sea surface temperatures kind of escalate. So this is just showing this year the gradual increase in sea surface temperatures taken at a specific location there in the Pacific. So we can see that it's on a gradual incline. Now there is a little bit of some oscillation, you know, kind of varying back and forth, but for the most part, we are on a gradual incline still as we head into now the month of August.
Real quick, if I can. So
cut in there. Go ahead.
So technically, to have a La Nina or to have an El Nino, the temperature has to be at least 0.5 degree Celsius above or below.
Oh my gosh, this is a very important thing. I don't know why I haven't brought this up. Yeah.
So as you see, we started back there in May. We kind of went into El Nino there in like April and May. So it has to be 0.5 degree above normal Celsius for 3 months straight. And if that happens, then you are in an El Nino if it's above, or you're in an La Nina if it's below. And so we clearly have been in an El Nino pattern since, you know, April, maybe very early May. And as you said, a gradual increase.
And they say, you know, kind of the average, you can average about 9 to 18 months of being in a, by definition, La Nina or El Nino. There are also neutral. So meaning it doesn't waver, it kind of wavers 0.4 degrees warmer or 0.4 degrees cooler. And it's just in that wavering. That's kind of what we consider those neutral points.
La Nada.
La Nada?
That's what people call it
sometimes. Is that another made-up term?
That's a made-up term. Like warm blob. La Nada.
That's the most unscientific term ever. I also just want to say real quick, share this video because we're going to answer questions at the end so that way people can watch this live and ask questions. We might not be able to answer everybody's questions. We may have some repeats, but okay. So air pressure in the jet stream. This is the biggest thing because it technically air pressure in jet stream. This is what feeds our season or how we kind of feel those changes, especially in the winter time. So it all is dependent. Even now we've got storms coming in and that is dependent on the jet stream and pressure system. So our change in weather is pretty much always dependent on that. The reason that we have the fluctuation in air pressure and jet streams is because of the sea surface temperatures. So the jet stream, just kind of reading here, is the dividing line between that cold air and that warm air. And when you have that stark contrast, that's when you get kind of those bigger weather changes. So when we see severe weather is because we see a even quicker fluctuation or a stronger differentiation between those warmer and cooler air pockets. So this transports all the air around through the jet stream. Think of it as the highway in which the atmosphere kind of flows. Yeah, it's like the highway of weather. You know, the jet stream, it moves that warm and cold air in and out. And so that, I just wanted to kind of explain how that all works together. So here are El Nino and La Nina map, or the years, and we can kind of see we've got strong, very strong, moderate, weak. So within El Nino and La Ninas, there are even categories within that. Explaining if they're weak or strong, and that is what dependent of how long they're in an El Nino or how warm the temperatures are within it.
Yeah, how much above or below normal the temperatures are, and you know, so very strong. You know, you're getting up there to the 2 degrees Celsius or above. So it's based on the temperature of the sea surface water.
Gotcha. All right. Sea surface temperatures, SST. If you ever see that, now you know you can talk like a weather expert. So it typically ranges, this is what the average is. So this is what they go off of the baseline, 75 to 80 degrees. And if it goes above or below that, that's when they start to see, okay, is this pattern shifting towards an El Nino or La Nina? And again, they look at the difference of 0.5 or half a degree Celsius, higher or lower. So we've kind of already went into that.
Can we go back to that real quick?
Oh, wait, yeah, because we need to talk about the
regions?
Yes.
Yeah. So if you see, we always really talk about El Nino in what's called Niño 3.4.
Which we've got in the little black box. You can see that.
Yep. So the blue box is the 4, and then the red box next to it would be the 3. And so we basically kind of divide those right down the middle, and so that's Niño 3.4. And then a small section next to South America is Niño 1.2. So if you ever hear us talk about, we usually refer to 3.4, but you also have Niño 1.2, which I think you might have some stuff on that coming up. I'm not sure.
I think so.
Okay.
Like I said, a lot of graphics.
Yeah.
We're trying to go through these. Okay. So again, you sent these graphics in. So take it away.
Yeah. So look at the bottom and you'll see those dates. So if you look real close, you'll see 82, 83, 97, 98, 15, 16. Those were the really, really big ones. Now there's some others that are in there, but then the very first one, remember I talked about 1877 to 1878. There was another one in the late 1800s as well. The whole point on this is going back to 1870. And if you look at where we are here in 26, 27, we're ahead of them all. We're ahead of everyone, including the big massive one that, again, relatable, how big was it? Because we didn't have good recording stuff back then. But the point is that we're ahead of everything. And that's why we're concerned about this becoming maybe the strongest El Nino it's uncharted territory. Uncharted territory.
And then here are just showing those other maps. And now this is showing in the region, right?
This is Niño 4. I think was the other one 3 or 3?
It was, yeah. So again, going back, we're talking about Niño 3, Niño 4, when we're looking at the different areas of sea surface temperatures. So you can kind of see there in Niño 4, again, we are going into uncharted territory of the warmest recorded sea surface temperatures there. This is there near 2, so that's very close to the coast of Peru.
Yeah. And what I wanted to say about this one actually I actually use this in my winter outlook. So this not only takes into account the sea surface temperature, but we also look at the sea surface pressures. We look at the zonal winds, which you talked about, and we look at the outgoing long wave radiation. So this is really probably the best tool to use because it takes into account more than just the sea surface temperature anomaly. And as you can see, we're and again, this is in 79 because we weren't doing it. We couldn't really go back and find those, but we're ahead of everything. So it's I just think that I think we're headed for uncharted territory, and what will it mean for us? I mean, we're going to talk a little bit about that, but we don't know for sure.
You got a lot to study in your winter outlook.
I know.
He's stressing you guys. He's already made comments to me. He's like, man, this is going to be Because you don't like to be wrong.
I don't like to be wrong.
But you also grade yourself for the Walker Winter Outlook,
mhm.
and you know, a lot rides on it. His own pressure on himself.
You've seen my scribbles, my files.
Yeah, I made a comment that this year we're gonna put everything on actual like Google document, like docs and sheets and stuff.
I'm old fashioned.
Hey man, that's fine. I got a notebook beside me, but that's like, it needs to be archived. It needs to be preserved. You can't just throw it in your notebook. Yeah. All right. And then this is kind of the last graphic. These will be the last of these kind of messy looking graphics.
Yeah. So what we're looking at here, this is the projection. If you look, there's a green solid line. That's one set of models. I would prefer to look at the brown one. That's more models I look at. So basically this shows it peaking sometime probably like in November to December. And if you look at where it peaks at around 3. Some of the models take it higher than that. But as a general rule, I would say you're peaking at about 3 degrees Celsius above normal. Clearly the strongest in recorded history, maybe not quite to that 1877 one, but that's a forecast.
And just because it peaks in November, think it takes a while for the weather to actually progress into our area. So meaning if it peaks there in November, that might mean the second half of that winter time is warmer. But that's why we see a lot of snow events in El Nino years in November, is because it hasn't actually caught up to that warming pattern yet. So it's all, you know, in a flow. Okay, strong El Nino years, the warmest warm phases. So these are kind of just showing how much warmer. So again, anything 0.5 degrees Celsius or warmer for 3 months or more is considered that El Nino phase. And look at these, 2 3/4, 2 and almost a half degrees Celsius, and 2 and almost a quarter degree Celsius warmer. So way warmer temperatures there. And these were strong El Nino years. And again, just wanting to reiterate and show this map, if you want to take a screenshot of this on your phone, just so you kind of have a reminder of, okay, what were strong El Nino years? And maybe you can even remember the fall or the winter of 2015, 1997 and 82. Maybe you can kind of remember those as being a little bit warmer. And then versely, strong La Nina years, 2010, that was the last white Christmas we had.
Yes, the last official white Christmas in 2010.
And that's kind of not, I mean, we can have an El Nino year where there's possibly snow there in December, but that was the last, by definition, white Christmas was actually on a strong La Nina year.
You can't stay on that for a second. So, so interesting side note, not all El Ninos are the same. Now, when we get to very strong and strong, we tend to follow a path. But look over there on the weak El Ninos. And those of you who are watching this, maybe been around here for a while, you might recognize 76, 77, and 77, 78. 77, 78 produced the blizzard, last actual blizzard we've had in this area. And 76, 77 produced one of the coldest, actually both of them, two of the coldest winters ever on record. So just because we say it's an El Nino, it could be a weak over one and where it's located, but it produced some of the coldest winters and a blizzard even in an El Nino. So just because it's El Nino, it doesn't mean it's going to be a really warm.
Yeah, it's not a hard yes of going to be warmer. And just something, so that way, if you ever like, I kind of get them mixed up, El Nino and La Nina. El Nino, we always refer to there in red because we're indicating warmer winters, and La Nina in blue because we're indicating cooler winters. So that's also just a little helpful tip with that. So here we've got 2026, right now what we're in, 2015, which was an El Nino year, and then 2010, which was a strong La Nina. And you can, again, just see here how there was a lot warmer of temperatures. I mean, look at that, 29 degrees Celsius sea surface temperatures in July of this year, but July of 2010, it was 26 degrees. That's a fairly big difference. That's a very big difference.
Well, when you're talking water, think about how much energy it takes to warm water, or even energy to lose to cool water. So when you're talking that big of a difference, that's huge. But again, it's the difference between a very strong El Nino and a very strong La Nina.
And then again, just showing here, I'm not going to show 2026 because we don't have all the stats on it, but I wanted to highlight this. Again, 2015, strong El Nino year. 2010 was a strong La Nina. El Nino normally means warmer winters. La Nina means cooler. There in December, our average temperature was 51 degrees. Average high temperature was 51 degrees. in December of 2010, the average high temperature was 31, 20 degrees difference. So people that like to say, it doesn't really matter. Oh my gosh, we had a warm day in this year and it's a La Nina. Well, it's not overall. We like to always take the averages. That's what the sea surface temperatures are. They're averages. We averaged it over that 3-month period. So are we going to have maybe a cold push still this winter? Absolutely. Like, it's not going to be 50 degrees every single day, but the average, it might be a lot warmer and also see a lot less snow. And there on the side, we can see precip. So, 13 days in December, did we have precip? So not necessarily drier, but only one of those was a snow day. In December of 2010, we had 18 days of precip and 11 of those were recorded snow. So again, take a screenshot so that way if someone ever wants to fight you on El Nino, La Nina, and it doesn't matter and this is a really good representation of strong years. And again, we're going into a strong El Nino. So we can kind of look at this and say, yeah, it might be a little bit like this. Weather is never an exact copycat.
Right.
Every severe storm is different, just like every winter is different. But you can see here that especially in December, January, and February of El Nino, it was a lot warmer and we didn't see as much snow as we did in those La Nina years. Now let's talk about drought conditions. So we've got the winter time, but obviously winter time kind of sets you up for the springtime. So we're going to forecast a little bit out of what we've seen weather patterns because again, drier conditions in the winter time, and you've said this before, a drought feeds a drought. Normally that's in the summer months, but we can also see that in the spring months. So this was spring of 2016. So this is following a strong El Nino winter. And this was the drought conditions. Really, what is that? Extreme drought over there in California and Nevada. But over in our area, not as bad. It's, pretty relative. I took all of these estimates, I believe, at the beginning of April or mid part of April. And then we have the spring of 2024. So again, leaving an El Nino year. We had a little bit of an onset drought, but a lot of it is way more out to the west of us. This was a little bit more of an unprecedented year because looking up there in Iowa, I mean, you're getting into severe drought. But this is the big difference. So we can kind of see here, a little bit of a drought out there in mainly California, but then here as a La Nina year. Big drought setting up in, the lower part of the plains and also out west. They're in Texas, Oklahoma, Kansas. And that all has to do with, during an El Nino year, they talk about a lot of moisture down there in the south. Well, in La Nina, it's a little bit flipped and we get more moisture up there in the Midwest and then the plains. And so this is just a direct vision of how we can kind of dry out there in La Nina years just as much, but it locates it differently.
Yeah, and this was important too, because what this did to us in the spring, early summer of 2011, when it's really dry in the southern plains, you tend to shift your spring severe weather north and northeast of that drought area. And of course, those of you who watch weather know what happened in Joplin, Missouri in May of 2011. They had an EF5 tornado, unfortunately the 7th deadliest tornado in U.S. history. And then we had lots of severe weather here in the spring and early summer of 2011. So a lot of times, and we came out of a La Nina, and look what we've had this year. A lot of times coming out of a La Nina winter, the severe weather season shifts north and more east. And last year, Illinois led the nation in tornadoes, and they're leading the nation.
Oh my gosh!
Yeah, they had
about to hit 200.
Yeah. So that's a case where El Nino, La Nina, even though its biggest impact is winter, it can impact our severe weather season as well.
Yeah. So again, this is what we're looking more in an El Nino. I don't want to say because it's drier that we're going to be in a drought in the springtime, because here's 2 instances where it was drier conditions in the spring, but it wasn't severe. It wasn't, super, super noticeable there yet. This is the last thing, and then we'll take questions. During El Nino years, statistically, I looked at the past 7, And out of the past 7 strong or moderate El Niños, 4 of them we had snow actually in November. Then we ended up having a much warmer, mild winter there in December, Jan, and Feb. But we actually had snow events in November. And then it kind of backed off because, again, it takes a while for those warm sea surface temperatures for that low pressure to set in and that high pressure to set over us in the Midwest. That's a very broad weather pattern we're talking about. Yep. So it takes a while for it to set in.
Yeah, I remember in 97, remember 97, 98, I've told you this story before.
I wasn't alive then, but
No,
sure.
yeah. I was. 97, 98, I had done my winter outlook and it was a strong El Nino. So I knew what was going on. It was going to be mild and there was going to be not much snow. And I said that. And then right after I'd done the outlook in November, we got 3 inches of snow in November. And I still remember a buddy of mine, he said, well, you want to change your outlook now? We already got 3 inches of snow. I said, we're good. Stay the course. It's an El Nino. And sure enough, because a lot of times you have it in November and then you don't see much after that. So we were fine.
And that's where I think a lot of the naysayers are going to come in. They're going to be like, you said it was going to be warmer and less snow, and then we might get a snow event in November. Well, it's okay. We'll sit back. We'll be like, just wait for the rest of the year. But yeah, so I think that's it. What we're looking for this year in an El Nino, especially with it being stronger, maybe a little kick at the beginning, some cooler temperatures in November. Statistically, 4 out of the 7 strong El Ninos, there was snow in November, and then again, it backed off. Not necessarily saying that there are going to be drier conditions setting in for the spring just because it's drier in the winter. So we'll kind of take any questions that we have here. Again, share this video so people can watch it, be informed about El Nino. We talked about a lot. So if it's helpful to kind of go back and listen to this again, or just kind of take screen captures of the graphics, that can kind of be helpful. Because it took me a while to kind of process pressure systems and how it impacts us in El Nino versus La Nina. But a lot of people happy about the Jesse Alex collaboration in the comments.
They are.
We wanted to talk about weather. We haven't done a video in forever.
It's been a while since we've done that.
Like
That's
what,
right.
3 months?
And you're like, I'm going to do an El Nino. I'm like, my gosh, we got to do
this. This is like your bread and butter, though.
Somebody asked me the other day. They said, I had some visitors at the station, and they said, what do you like most about what you do? And severe weather obviously is important because that's when it matters most. But I said, you know what? The other thing is these long-term forecasts. I'm kind of getting into these winter outlooks because it takes a lot of work. And I try, if I ever do a winter outlook and I mess something up, I try to learn from my mistakes. I go back, how did I miss this? So these winter outlooks really have really become a thing for me. I didn't think when we were doing them way back when it was going to be that big of a deal, but it has become that. And I enjoy doing, a couple quick stories real quick. And we'll see if people got questions. I remember in 82, in 1982 on Christmas, at the time was the warmest ever. We were in the mid 60s and we had thunderstorms on Christmas Day. And I still remember in 97, another big one, I actually cut the grass. We used to have a lot of people over at our house. I cut the grass on Christmas Eve.
Dang.
Yeah. So that just tells you a strong El Nino is typically.
I need to cut my grass tonight.
Can you get on that?
Oh my gosh. We've had so much rain. And guys, we're going to have more rain coming around, the center of the Wabash Valley, 2 inches by this Saturday, at least, in areas. So if you cut your grass this weekend, you're probably going to have to cut it again this coming weekend. We've got a question where did that go? It went away. Well, it didn't go away. I just lost track of it.
You lost it. Okay.
Someone was asking about like the Great Lakes and how does that, now I can't find it. It was something asking about like, how did the Great Lakes impact El Nino? I don't know where that went.
Huh. Not really. I mean, so what happens is it just changes the, what's that? I Want a White Christmas. Can you make that happen? Love seeing you guys back together. So
El Nino, we're saying it's less likely for there to be a white.
I mean, we can go ahead and put that in a winter outlook. It's not going to happen.
Whoa, that's
I'm just giving it away right
stating
now.
the fact, guys. He just said something that he's going to put in his winter outlook early. Holy cow.
No snow days at Shakamak? Well, I wouldn't go that far to say no, but not very many. It's just the El Nino winters that are strong just typically are mild and not a lot of snow, but you can still get some snow. And you're right, the last white Christmas.
Oh, I know, Virgil. I went and talked to Shaq Mac back in the
Oh, did
spring.
you? Oh, yeah. Okay.
What's up?
Mitch says he deleted it and asked again. So see if you can see Mitch's question. But I think he had something about the Great Lakes. And if you had a question about that.
Maybe. I don't know.
So real quick, definition of a white Christmas. There's a true definition.
There is.
You have to
You talk about it every year.
Yeah, because, you have to have 1 inch of snow covering all of the ground on Christmas morning. So in other words, if you get up Christmas morning, there's no snow on the ground, and then 3 in the afternoon, you get 4 inches of snow. Technically, that's not a white Christmas. We have to have a definition so we can keep track of it,
Yeah.
So, or you have, a trace amount of snow or whatever. But the last time was in 2010. I remember working Christmas Eve, and a system came in after everybody had been done shopping and going out to eat. Everything was closing. We got 1.5 inches of snow. And I remember leaving the station that night in the parking lot, and the moon was coming back out, and we had 1.5 inches. It was perfect. We had 1.5 inches of snow on Christmas morning. So 2010, that's how long it's been since we've had a true, by definition, all of our area white Christmas.
Man, I was this tall.
Just a young type.
Yeah.
Will this make for more ice storms, says Gloria? So yes, it can. Not so much for us. More south of here, I would be more concerned places like Kentucky, Tennessee, the Carolinas, because the southern branch of the jet is stronger there, and you get sometimes these intrusions of cold. That's one thing I'll talk about in the winter outlook, but generally not so much in this area.
Yeah.
Mitch, did you get? Oh, yeah. Did we talk about the one from Mitch or not?
I don't know.
Okay.
Okay. Yes. My question is, do the Great Lakes moderate an El Nino or La Nina effect? Okay. So not really. Here's the main thing with what the Great Lakes sometimes provide us is with clipper systems or some snow there, maybe on the southward side of the Great Lakes. Here's why is when you have warm air going over cooler waters. And again, you kind of have to get into more of the cooler months in the winter time, because if it's warm air going over warm water, it's not really going to do anything. But when you have warm air going over cooler temperatures, it cools that warm, moist air, and then it creates snow on the other side of the lake, or depending on where the wind is blowing. So if it's, blowing eastward, then it's going to possibly create some snow there. In Michigan, we actually had some lake effect snow this past year. And I want to say that's what the December 1 snow that we had, right? The December 1st. I was filling in for you, actually.
Yeah.
And we did have some snow, and a lot of that was actually lake effect snow. But keep in mind, you have to have cool waters there on the lake. And if we have a very mild winter, it's not going to cool those, even those temperatures down there in the water. So
yeah, lake effect
snow. Yep. Well, this effect when we will start seeing cooler temps, like later or sooner, a little bit. And we were kind of talking about that. It takes a while for the sea surface temperatures to actually make its way and have an impact us here in Illinois and Indiana. So it might actually be still our normal November. Although last November we had like a 70-degree weekend.
Yeah.
I remember you went to a wedding.
My niece.
Yeah. And it was like, great for her and
Yeah.
all your family. It was 70 degrees. But then we had much, much cooler conditions in December and January. And we're kind of saying that it might be a little bit the flip side of that. Maybe a little bit cooler there in November, mild, and then extremely mild in December and January. Doesn't mean that we can't get a cold snap. We're not saying that at all, but averaging pretty mild for December and January. And then February is such a toss-up month anyways. Even looking statistically, the difference between a La Niña and an El Nino year in February, a couple degrees. It's not compared to December where there was a 20 degrees difference. That's huge.
Yep.
Yeah. Okay. No new question. Oh. How was the years through the 30s Dust Bowl compare with now? I don't really know much about El Nino stuff when there was like the warmest.
Yeah. So, I talk about this a little bit sometimes. Sometimes people will say, well, have we ever, by the way, the most snow we've ever gotten in the Terre Haute area was in 1981-82, and we had 63 inches. 14 and a half is average. So we had 63 inches of snow. And then people will be like,
oh
well,
my gosh.
Yeah, 5 feet. 5 feet of snow. And the next year was an El Nino, and we got basically nothing. But anyway, it's crazy. But people will say, well, have we ever gone a winter with no snow? And the answer to that is no. In the early 30s, I think it was 1933, we had literally 1/4 of an inch of snow all winter. But think about the 30s. The 30s, especially the early to mid 30s, was the drought, and the Dust Bowl. So we didn't have a lot of moisture. So, but the 30s, though, if you go back and look at them, dry air heats up and cools off quicker. So our hottest temperatures were recorded in the 30s in the summer, but we have a lot of record low temperatures in the winters of the 30s because, again, moisture in the air tends to keep the temperatures more consistent, like if you live near the ocean. So we had a good variation, but we went through the parts of the 30s with very little snow because we had very little moisture.
Isn't this cool, guys? Like everything, you know what I mean? Like everything is impacted in some way, like whether it's drier or whether it's wetter, or whether it's warmer or cooler, and what happens. This is why everything, whenever we did like school visits, I would always say like the earth runs like a treadmill. If you put a dot or whatever on the treadmill, you're going to see that come back through, but maybe it might mess something else up. So everything is basically, as far as weather goes, it's on a treadmill. And so it's all going to somehow impact when it passes around a different continent or part of the world. So does that mean we may have more severe weather through the winter months than we normally would have? A little bit. I mean, when you have milder winters, that means, again, warmer temperatures. And when you have that stark contrast, we did still have severe weather right there at the end of December. The one weekend I took off.
December 28, I think. Linton.
Yes.
Yeah,
and
I worked.
The one weekend I had to use that time off. And,
end of the year,
and I was like, oh my gosh, the one weekend I took off, and you got severe weather in December, and it was an EF0, F1 there in Linton. And I was so jealous.
Yep.
Not jealous as just the fact that you got to track some in December, but then we got to track some in February. So
the biggest outbreak in our area ever in February. February. So in the El Nino winters, we tend to see an uptick in some people from here go to Florida in the winter. So we
had someone watching from Florida. I don't know who, it was way earlier, but someone was, yeah.
Yeah, so the subtropical jet is stronger. I remember in 97, 98 winter, there was an early outbreak of pretty bad tornadoes in Florida. So we do typically see a more active severe weather, Texas, Gulf Coast, especially Florida, during El Nino. So I would probably say we're going to be looking at a lot more severe weather in the southeast part of the country. But you're right, because our temperatures are warmer, we would tend to probably see more active weather potentially in terms of rain and or thunderstorms in the winter months. Whether or not they're completely severe, maybe not. But I mean, it is
hard to predict that, honestly, because there's a lot of instability factors that go into that. But lastly, we're not getting any new questions, so we'll kind of sign off here. But we are looking at some severe weather tomorrow, so I just want everyone to kind of be aware of that. They're in northwest and southeast central kind of Indiana. I think we both posted about it on our Facebooks or whatever. But we're looking at severe weather and enhanced risk. So that's a level 3 out of 5. The timing on that's going to be there in the late afternoon hours, starting at around 3 p.m. Eastern time. In the southern Wabash Valley, so kind of near the Knox, Davies, Martin, Lawrence, even over there on the Illinois side, kind of talking Jasper, Richland, Lawrence, Clay, County, Illinois, maybe not as much severe weather, but there in those northern parts, we could see some, at least stronger winds as that front's coming through. So
yeah, we think we'll probably get a development in Iowa, and then it will move southeast. Those are typical wind producers. And sometimes people throw around the word derecho, which the last time we had one was in 2023. This could have the earmarks of that somewhere. I don't think on us, but north and east of here. I mean, if you're producing 58 mile per hour winds or greater over a 60-mile wide area for at least 400 miles.
400, which is
they update. That used to be on 240. Now it's 400 miles.
Man, they're getting
it's harder to get a derecho.
Stingy.
Yeah. But yeah, I think we got to keep an eye to the sky tomorrow, be weather aware. But I agree with you. I think north and northeast of our immediate area, probably a little higher risk. of those storms. So
someone's asking August and September, we actually see more warmer and actually drier. It's looking to be, I was looking at some drought monitor stuff at the end of August, and we kind of dry out a little bit. So that's kind of the way it's leaning. But anyways, well, thanks for being my guest on. You're like, yeah, no problem.
I was coming through town.
Yeah, you're like, whatever. I hope you guys enjoyed. Again, share this video. Thanks for all you guys that participated, asked questions. Thanks for everybody who just kind of followed along. And yeah, maybe we'll do more of these. Who knows?
Kind of fun.
We just like to talk about weather. So
and say warm blob.
Warm blob.
Now we learned about that.
There we go. All right. Take care, you guys. Thank you for tuning in.